everyone, today we are going to solve the KVS question paper of last year, that is for the subject PGT physics. And in this part of the video I am going to solve the first 5 questions. And the first question is given the energy, if energy E, V and force are taken as fundamental quantities, then the dimension of mass will be. Now the energy E having the dimension m L square t to the power minus 2, the velocity having the dimension L t to the power minus 1, and force having the dimension m L t to the power minus 2. Now this question is little tricky, as because you can see, to solve it, if I do this one, if I take v square, squaring the both side of this one, then it will become L square t to the power minus 2. And if I take the ratio of this E and v square, A by v square, then it will become m L square t to the power minus 2, and there will be L square t to the power minus 2. So remaining will be only m. So the dimension for m in respect of energy, velocity and force, it will be E by v square. Moving to the next one, there is a question number 82. We have to find the number of significant figures. Now from the rule of those significant figures, the total number of digits in between two non-zero digits, we have to consider all of them as significant figures. Now the number it is they have given, it is 6.00023, and moreover you have to remember the unit also given over there. This one is this unit. In other videos we will discuss about the unit, what will happen to significant figures if they provide us the number with unit. It's a very important thing. So here it will be 1 2 3 4 5 6. Then the answer will be 6. Total number of significant figures will be 6. Moving to the next question. There is a question number 83. They have given a viscous liquid of density rho, density rho, and tube of radius r with a velocity v. So to find the Reynolds number, that is Reynolds number they have given. They ask us to find out what is x. To approach this kind of question, we have to go through by dimensional analysis. We have to keep this in mind. We have to solve this such of type of question in the concept of dimensional analysis. So if I write this equation here, r is equals to kxy rho r v. Now Reynolds number is dimensionless quantity, so it will be 1, and in the question they have given k is also dimensionless quantity, then it will also be 1. X we have to find out. Rho is density, so the density dimension is mass by volume, that it will be ml to the power minus 3. Rho radius, there is a dimension of length, and velocity it will be L t to the power minus 1. So if I solve it, the dimension of x will become m L to the power minus 1 t to the power minus 1. Now if I go to this concept, surface tension, viscosity, surface tension, acceleration due to gravity and pressure, the pressure dimension all we know, m L to the minus 1 t to the power minus 2. Acceleration due to gravity, acceleration is having L t to the power minus 2. And the formula for viscosity, viscous force, from we have to derive it from viscous force. The formula is F is equals to eta a dv dx. Vectorically there will be minus n, but I am not considering the vector over here. just considering f equals to a dv dx. So if I place the dimension of all the quantities present here, force, here eta is viscous, coefficient of viscosity, and a is area, v is velocity, x is length, and dv dx is velocity gradient. Remember this term, velocity gradient. So force will be, dimensionally force will be ml t to the power minus 2. Eta we have to find out, dimension of a, that is area, is l square. dv, that is velocity, dimension of velocity will be l to the power lt to the power minus 1, and for dx it will be l. So finally eta will become, after calculation, m l to the power minus 1 t to the power minus 1. Moving to the next question. This is also very interesting. A point object is moving with uniform speed v in circle of radius r. Then with the frequency of its motion, the acceleration of the object will be. Now, as the object is moving in a circle of radius r, we have to consider centripetal acceleration. The formula is centripetal for the formula for centripetal acceleration is v square by r, and also we know v is equals to r omega whole square by r. It will be by simplification omega square r. Also we know omega equals to 2 pi n. So if I place it in place of omega, this one 2 pi n, centripetal acceleration will become 4 pi square n square into r. This will be the equation. Now moving to the last question of this part. This was one of the easiest question I have seen in this paper, and the question is, the position of 4 objects A, B, C and D are given with the following equations where time t is in seconds. Which of them is moving with uniform speed? So the concept is uniform speed. Now when this uniform speed will come into picture, that means the acceleration will become 0. If the acceleration is becoming 0, that means d2x by dt2 will also be 0. That means among 4 equations we have to choose, after the second order derivative, which equation will become 0. Now if I look at this second option, if I take the first order derivative, dx dt equals to, it will be d dt of minus 5 plus 2.0 into t. The result will be 2 dx dt, that is velocity dx dt equals to 2. And if I take the second order derivative, that is dv dt, also which is, you can write d2x by dt2 equals to, and the 2 is constant, that is d dt of 2, it will become 0. So for today it is up to this much. The rest question I will discuss in the next video.